Okay, so as I told you in last class, in next class I'm going to take one numerical problem on heat energy and heat dissipated, right? So this is your question. I have already written the question on the blackboard, and now I'm going to solve this question, right? So in the last class, I trapped the formula somehow like this: heat energy consumed, right? Energy consumed energy consumed in conductor is W, and that W is equal to V into Q, right? That W is V into Q, right? Okay, yes, V into Q. Have you remember this formula? Okay, V into Q. Okay, in that they have written this one delta Q, right? So further we can write it. Delta Q is basically, Q is equal to IT, right? Q is equal to IT. Yes. So similarly we can write here, from here we can write Q is equal to, I is equal to QIT. I is equal to QIT. So Q is equal to I into T, right? So for this one, in place of B, we can write, in place of delta Q, we can write this one, I into delta T, right? The delta T is time interval, right? Okay. So what formula is coming? Vi delta T, right? This energy consumed by the conductor is basically appearing in form of heat, right? This energy consumed by resistor is appearing in form of heat, right? So further we can write H is equal to Vi delta T, right? So H is equal to Vi delta T, right? Okay. Some more changes I am going to do in this one. So H is equal to Vi delta T, right? And delta T is time interval, right? Okay, delta T is time interval. Okay. Ohm's law, right? Ohm's law is what? V is equal to IR, right? So in place of this, we are able to substitute this one, right? So if I am going to substitute, so here IR will come from here. I am now writing here, right? So in place of V, IR will come, and one I is already here, and delta T. So what formula is coming? I square R delta T. So this is another formula to heat dissipated in conductor, right? And further we can write like this also. From this relation, another formula again I am going to derive. So H is equal to, we can write here I can be, from here you can see I is equal to what? I is equal to V by R. Yes or no? I is equal to V by R. So here so we can substitute V by R, and this is your delta T, right? So further formula will come D square by R into delta T. So H is equal to, this is like this. This is your another formula, right? So basically these three formula you have to remember to calculate heat dissipated in a conductor, right? Okay, so now we are going to solve this question, right? So first we have to write the value given in the question. Now you can see the resistor develops this amount of thermal energy, right? Thermal energy means the heat dissipated in form of heat, right? And how much is that? 400 joule, right? So given H is equal to 400 joule, right? In 10 seconds. So time interval is given, delta T is given 10 seconds. You can see here, right? When a current of 2 ampere, right? So I is given 2 ampere, right? So what we have to find resistance. Find resistance. So formula is known to you, right? So using that formula we are able to get the answer, right? So from here this formula is useful to calculate the answer, right? So F equals to I square R delta T. So from here we can write R is equal to H by I square divided by delta T, right? H is given in the question and this is how much? 400 and I is 2 square and delta T is 10 second, okay? So this is this cancel and 2 square is 4, so here 10 will come. So resistance is how much? 10 ohm, right? We calculate resistance, okay? In next question, okay? So now first question is that we have calculated resistance. In second they are saying if the current is increased to 4 ampere, right? Now I becomes how much? This is your A part, okay? And now B part we are going to solve. So in B part I becomes how much? I is becomes 4 ampere, right? And what we have to find? Energy developed in 10 seconds, okay? Energy developed in 10 seconds. That means again we have to find heat, right? Okay, so you know formula H equals to I square R delta T, and I is how much? I is 4, so 4 square into R is given, we calculated how much? 10 ohm, and delta T is 10 second, right? So 4 square is 16. So if we are going to, we will get the answer 1600, and this is energy. Answer will be joule, right? So if this way, this formula is useful to calculate heat dissipated in resistor, okay? That heat is dissipated in form of thermal energy. Thermal energy means in form of heat, right? Okay, so note it down, and next we are going to discuss combination of resistor, okay? Okay, so in last chapter we have discussed combination of capacitor, right? But in this chapter we are going to discuss combination of resistor, right? Combination of resistor, okay? Combination of resistor, right? So to understand combination of resistor, first I am going to discuss equivalent resistance, right? Equivalent resistance. First I am going to discuss equivalent resistance, okay? Equivalent resistance. So you can see here, suppose I am going to take combination of a capacitor, combination of a resistor, right? Suppose resistor are connected like this. So these are the combination of resistor. Any random. This is not series, this is not parallel, right? So see, resistance is connected like this. Many connected like this also. Okay, so this is any random combination of resistor, right? And we are going to find R equivalent, right? Equivalent resistance means is represented by R equivalent, right? This one we are going to calculate, right? R equivalent we are going to calculate, and this is your combination of resistor, right? How we can calculate R equivalent? Okay, now you can see. So just connect this. See, this resistor have two terminals. One is this one, another is this one, right? So just connect the battery across this terminal, right? So I connected battery across this terminal, and that battery is having potential V, right? So due to this battery, as I connected batteries, so current is start flowing this one. So if I current is flowing in this one, right, then R equivalent will be V by I. Then R equivalent will be I. So what you will do to find R equivalent? So just connect the battery, okay, and if battery having potential V and current is flowing I, then R equivalent will be V by I, right? Okay. So this way we are able to get the value of R equivalent, right? Next, we are going to discuss in combination of resistor. Two types of combination we are going to discuss: parallel combination as well as series combination. Okay. So, how many combination of resistor is? First, parallel is series combination, and another one is parallel combination. Right. So first I am going to discuss series combination. Okay. Series combination. Right. So series combination. So see, if resistors are connected like this type of combination of resistor is known as series combination. Okay. Right. Suppose this one is R1, this is your R2, this is your R3, right? And battery is having potential V, right? So current will start flowing in this one, and that current will be I, right? You can see here, if I current is passing through this one, same I will pass through this one, right? So that means same current is passing through each resistor, right? So we can say if current in each resistor will be same, right, then that combination of resistor is known as series combination, right? Okay. Or so we can write in series combination current through each resistor is same. Now see, as current is passing, there will be potential drop across this one, right? There will be potential drop across this one, there will be potential drop across. This is your V1, and that V1 will be IR1, right? And this is your V2, that V2 will be IR2, right? This is your V3, that will be IR3. And now see, and this V is basically sum of this one plus this one, right? So further we can write V is equal to V1 plus V2 plus V3, right? Okay, and V1 is IR1, this is IR2, and this is IR3, right? So here I we can take common. So what value we have? I1 R1 plus R2 plus R3. So V is equal to how much is 10? I is equal to V is equal to I into R1 plus R2 plus R3, right? And already I have defined R equivalent, right? And I have defined R equivalent. What was the R equivalent? R equivalent is here what battery is connected V and current is I. So R equivalent will be V by I. I already defined this one, right? So from here we can write V is equal to I R equivalent, right? So this is your equation 1, this is your equation 2, right? So from equation 1 and 2, so from equation 1 and 2, we can write IR is equal to I into plus R2 plus R3. This I cancel, so R is equal to R1 plus R2 plus R3. So this is your formula for series combination of resistor, right? To find R equivalent. Okay. So note it down. Okay. So you have written this part, no? Here I have taken only 3 resistors, right? But this formula is valid for any number of resistors, right? So we can write for n number of resistors, right? For n number of resistors, for n number of resistors, R equivalent is equal to R1 plus R2 plus Rn, right? Now next we are going to discuss parallel combination. Okay, so this part you have written. Okay, so write it first and then I will discuss parallel combination. These things are already discussed in your class 10th, right? So that's why I'm trying to finish this one in fast, right? Just take it as a revision, right? Okay. So parallel combination, okay. So see, if resistor is connected like this, then this combination is known as parallel combination, right? So this combination have two terminals. One is this one, another is this one. So I'm going to connect battery here, and battery is having potential V. So due to that, the I current is start flowing in this one, right? See, this I is going to divide into this. I will come here, right? At this point, this I is going to divide into 3 parts. Suppose I1 current is going in this direction, I2 is going in this direction, and I3 is going in this direction, right? Okay. Now you can see here potential drop across R1 is V, because R1 is connected across battery of potential V. Similarly, potential drop across R2 will be V, because this one is also connected to a battery of potential V, right? And R3 is also connected to battery of potential V. So you are able to see here potential drop across each resistor is same, right? Okay. So if potential drop across each resistance is same, then that combination of capacitors, combination of resistor is known as parallel combination, right? So we can write in this combination, potential drop across each resistor, across each resistor is same, right? Now from here you are able to see here R1, through R1 how much current is passing? I, right? So we can write here from I is equal to V1 R1. So current through resistor R1 is I1, right? And that I1 is V by R1, right? From where this formula is coming, this is, you are able to understand V is equal to I, right? So I is equal to V by R. Okay. Similarly, we are able to find current through resistor R2, right? And that will be, the current through resistor R2 will be I2, and that I2 will be V by R2, right? And I3 is V by R3, right? Okay. Now here this I is going to divide into three parts. At this point, your I is going to divide into three parts: I1 plus I2 plus I3. So I will be sum of I1 plus I2 plus I3, right? So I is equal to I1 plus I2 plus I3, right? And your I is how much? V by R1. This is V by R2. This is V by R3. Further we can like we can take common, so you have 1 by R1 plus 1 by R2 plus 1 by R3, right? So I is equal to V into 1 by I R1 plus 1 by R2 plus 1 by R3, right? So suppose this is your equation 1, right? Okay, and I have already defined R equivalent, right? R equivalent is what? R equivalent is V by I, right? So from here you are able to see that I is equal to V by R equivalent, right? This is your equation second, right? So equation 1 and equation second. So from equation 1 and 2, what formula will come? V by R equivalent is equal to V by 1 by R1 plus 1 by R2 plus 1 by R3. V cancel, so 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? So here I have taken only 3 resistor, right? Here I have taken only 3 resistor, right? But this formula, similarly we are able to write formula for any number of resistor, right? So you have written this part, right? So now I am going to rub this part. That one is for 3 resistor, right? So for n resistor, what will be R equivalent is equal to 1 by R1 plus 1 by R2 plus plus 1 by Rn. Okay. Current division, okay. Current division, okay. Now you can see. Suppose two resistor is connected into parallel, and here I current is coming, right? So this is your R1, this is your R2, right? So this I current is going to divide into 2 parts here, right? In this direction, suppose I1 is going, right? In this direction, I2 is going, right? In current division, we are going to study how much is the value of I1 and I2, right? Okay. So these 2 resistors is connected into parallel. So R equivalent will be what? R equivalent will be 1 by R1 plus 1 by R2, right? So further we can write R1 into R2 is equal to R1 plus R2, right? And so further we can write R equivalent is equal to R1 into R2 plus 1 by R1 plus 1 by R2. So this is one formula for 2 resistors connected in parallel. We are able to get the answer like this. Just multiply R1 and R2 and just add R1 plus R2, then you will get the answer, right? But in this question we are going to find value of I1 as well as I2. Okay. So as you see, your R1 and R2 is connected into parallel, right? So potential drop this one and this one will be equal, right? So suppose here potential drop R1 is V1, right? And potential drop R2 is V2, right? So R1 is equal to V1 is equal to V2 because both resistor is connected into parallel. In parallel competition, potential drop across each resistor is same, right? So from here we can see V is equal to I1 R1, right? And V2 is equal to I2 R2, right? Okay. So further we can write I1 is equal to R2 by R1 into I1 into I2, right? This way we are able to write. This is your equation 1, right? And you can see here your this I is what sum your this I is sum of this one as well as this one, right? So further we can write I is equal to I1 plus I2, right? And I is how much? I1 is this much, right? I1 is this much, R2 by R1 by I2 plus I2. So here I2 we can take common, right? So if I am going to take I2 as a common, so inside the bracket we have R1 plus R2 into I2. We are able to write like this, okay? So further we can write, this is your I is equal to this value, right? I is equal to, so you can see here, from here I2 is equal to what? I2 is equal to R1 by R1 plus R2 into I, right? So this is your formula to calculate. So from here we can also write I1 is equal to, see, if I am calculating I2, right, R2 is coming up. Similarly, if I calculate I1, so R2 will come up here. I2 R1, here I1, here R2, right? So formula will be R2 by R1 plus R2 by I, right? So using this formula, we are able to find the value of I1 as well as I2, right? I1 as well as I2. So next I am going to take one example, okay? And just we are going to find the value of I1 and I2. Where is the example we are going to take? Suppose two resistor is connected like this. Suppose this is your 6 ohm, right? This is 3 ohm, right? And this combination is connected to a battery. This combination is connected to a battery of potentially 12 volt, right? 12 volt. We have to find I1, I2, right? And R equivalent. We have to find I1, I2 as well as R equivalent, okay? R equivalent of this combination, right? So here two resistors is connected, right? So formula of R equivalent will be R1 into R2, right, by R1 plus R2, right? Your R1 and R2, 3 into 6, right? And 3 plus 6 is 3 plus 6 is 3 plus 6, right? So this one is coming 18 by 9, so 2 ohm. So answer will come 2 ohm, right? You calculated R equivalent, right? If R equivalent is not, then you are able to get the value of I, right? Because you know R equivalent is equal to, you know the formula, R equivalent is equal to V by I, right? So from here I is equal to V by R equivalent, right? Okay, and V is known to you, V is 12 volt, right? So this is 12 volt divided by 2, right? If you are going to cancel it, so 6 ampere will come, right? Your I is came, right? Next we are going to calculate I1 as well as I2, right? So I1 is equal to here I1 is present, right? Formula will be what? In denominator R1 and R2. in denominator R1 and R2 will come, right? Sum of R1 plus R2, but here I1, so in numerator what value will come? R2, right? Into I, right? So this is your formula, right? So R2 is how much? R2 is 3, right? So 3 by 3 plus 6, right? Into 6. So this is your 3 by 9 into 6. This is 3, this is 2. So answer is how much? 2 ampere, right? So I1 is 2 ampere. Similarly, you are able to calculate I2, right? And I2 is equal to this much, right? So I2 is equal to R2 by R1 plus R2 into I, right? Now R2 is how much? R2 is 3, right? R2 is, sorry, here R1 will come, right? And so your R1 is 6, and here 3 plus 6 into 6, right? So further we can write here 6 by 9, 6 by 9 into 6. So here 2, here 3, right? We can cancel it, okay? So 2. So 2 into 2, how much? 4 ampere, right? So here, so your this value is 4 ampere, this value is, this way we are able to get the value of I1 as well as I2, right? So that's all for today, okay? Next class we will discuss about cell, okay? Cell, combination of cell, okay? All those things we will discuss. So that's all for today, okay?